Geometric sequence. Geometric sequence is a sequence wherein the term is found by multiplying the previous term by the common ratio. Okay, so to understand this better, let's have an example. So supposing we have a first term, let's call this as a sub 1, and let's have its value as positive 5. And then the common ratio, this is represented by r. R is the common ratio. So let's give r a value of positive 2. Okay, so we need to find for the different terms. So supposing we have here a sub 1 is 5, and we need to find for the values of a sub 2. Okay, this is a sub 2, the value of a sub 3, and the value of a sub 4. So to find for a sub 2, we will just multiply the previous term. So our previous term is 5, and this is a sub 1. So this will be a sub 1 multiplied by the common ratio, which is r. So substitute the values. A sub 2 here, this will be equal to our a sub 1 is positive 5 multiplied by r, which is positive 2. Our a sub 2 is positive 10. We have here the value for a sub 2. And then let's find for a sub 3. A sub 3 here, this will also be equal to the previous term. Our previous term now will be a sub 2. So this will be a sub 2 multiplied by r. So substituting the values, we will have a sub 3. This will be equal to the value of a sub 2 is positive 10 multiplied by r, which is positive 2. So our a sub 3 now will be equal to positive 20. So we have here the value for a sub 3, which is positive 20. And then to solve for a sub 4, so a sub 4 here, so the same formula, the previous term of a sub 4 will be a sub 3, and multiply this by r. And then substitute the values. We can have the value of a sub 4. This will be equal to the value of a sub 3, which is positive 20, and multiply this by r, which is positive 2. So 20 multiplied by 2 is positive 40. So we have here the values for a sub 1, a sub 2, a sub 3, and a sub 4. So stay tuned, we will have some examples about geometric sequence. Geometric sequence. Our problem, we have positive 4, positive 12, positive 36, and we have 3 missing terms. Okay, so let's call positive 4 as our a sub 1. Positive 4, this will be a sub 1, a sub 2, a sub 3, a sub 4, a sub 5, and a sub 6. Now the formula for finding the missing terms in a geometric sequence, this is a sub n equals to a sub 1 multiplied by r raised to n minus 1. But if the geometric sequence has consecutive terms like this one, and the missing terms are on the right side, we may use this formula. A sub n is equal to a sub n minus 1 multiplied by r. But what is r? R here is the common ratio. So since it is the common ratio, this can be found by dividing the two consecutive terms. So for example, we have here positive 36 and positive 12. To find for r, we will just divide 36 and 12. So 36 divided by 12, this is equal to positive 3. Okay, so we will still have, or we will still arrive with the same answer if we will divide positive 12 and positive 4. So 12 divided by 4, this is still equal to 3. So the r here is constant in all consecutive terms. Now, let us find for a sub 4. Using this formula, okay, so this will be a sub 4 equals to a sub 4 minus 1 multiplied by r. So a sub 4 here will be equal to 4 minus 1 is 3. This will be a sub 3 multiplied by r. So a sub 4, we will just multiply the previous term, which is a sub 3, by r. Our a sub 4 here will be equal to the value of a sub 3, that is positive 36. Multiply this by r, which is positive 3. So our a sub 4 here will be equal to positive 108. And then for a sub 5. So a sub 5 will be a sub 4 multiplied by r. And our a sub 5, this will be equal to, our a sub 4 is 108. And just multiply this by r, which is equal to 3. And we will have here positive 324. How about for a sub 6? Our a sub 6, this will be equal to a sub 5 multiplied by r. For our a sub 6, this will be equal to, our a sub 5 is 324. Multiply this by r, which is positive 3. Our a sub 6 will be equal to 972. So again, our a sub 4 is positive 108. Our a sub 5 is positive 324. And our a sub 6 is positive 972. And they are our final answers. Geometric sequence, our problem, we have positive 7, positive 28, and we need to find the missing 3 terms. So we have here 3 terms that are missing. So positive 7, this will be our a sub 1. So this is our a sub 1, a sub 2, a sub 3, a sub 4, and a sub 5. Okay. So since we have consecutive terms here, 7 and 28, the original formula in finding a missing term for a geometric sequence is a sub n equals to a sub 1 multiplied by r raised to n minus 1. Okay, now we can use this if there are no consecutive terms, but since we have consecutive terms, we will use this formula, which is easier. So we will use a sub n, this will be equal to a sub n minus 1 multiplied by r. So for example, on our given, we have a sub 1 and a sub 2. Let us find a sub 3. So to find for a sub 3, our formula would be a sub 3 equals to a, our n here is 3, so 3 minus 1 multiplied by r. So this will be a sub 3 equals to 3 minus 1 is 2, so this will be a sub 2 multiplied by r. Okay. Now we have the value for a sub 2, but we do not have the value for r. So to find for r, the formula for r, this is the common ratio of 2 consecutive terms. So we have here 28 and 7, they are consecutive. So to find for r, we will just divide 28 and 7. Okay. So 28 divided by 7, our r here will be equal to positive 4. So we can now find for a sub r. So a sub r would be equal to the value of a sub 2, that is positive 28. So 28, and we will just multiply this by 4. So our a sub r now will be 28 multiplied by 4. We will have positive 112. So we will have here positive 112. And let us find for a sub 4. So the formula for a sub 4, this will now be a sub 3 multiplied by r. So our a sub 4 now will be our a sub 3, 112, multiply this by r, which is positive 4. So our a sub 4 now will be 112 multiplied by 4. We will have positive 448. So our a sub 4 is 448. Let us now find for a sub 5. So a sub 5 will be a sub 4 multiplied by 3. So substitute the values. Our a sub 4 is 448. Multiply this by 4. So this will now be equal to 448 multiplied by 4, 1792. So our a sub 5 is 1792. So we now have the values for our missing terms, a sub 3, a sub 4, and a sub 5. Geometric sequence. Our problem, we have positive 1 over 4, positive 1 over 2, and we need to find the next remaining 3 terms. So let's call 1 over 4 as our a sub 1. So let us call this as a sub 1. This will be a sub 2, a sub 3, a sub 4, and this will be a sub 5. So the formula for solving a missing term in a geometric sequence, this is a sub n equals to a sub 1 multiplied by r raised to n minus 1. But we can use this if there are no consecutive terms. But since we have consecutive terms, the 1/4 and 1/2, we can use this formula. For example, for a sub 3, so a sub n, this will be a sub n minus 1 and multiply this by r. So for our a sub 3 here, this will be equal to a, our n is 3, so 3 minus 1 multiplied by r. Our a sub 3, this will now be 3 minus 1 is 2. So this will be a sub 2 multiplied by r. So meaning to say, we will just multiply the previous term by r to get the present term. And to find for r, so what will be our formula for r? So r is just the ratio of 2 consecutive terms. So we have here consecutive terms, 1/2 and 1/4. So we will just divide. So 1 over 2, this will be divided by 1 over 4. Okay, so let's divide this. Our r will be equal to our numerator, and if we divide fractions, we will multiply them by the reciprocal. So we will have here 1 multiplied by 4 is 4, 2 multiplied by 1 is 2, and 4 divided by 2 is 2. So our r now is positive 2. We can now solve for a sub 3, a sub 4, and a sub 5. Okay, let us now solve for a sub 3. So a sub 3, this will be equal to a sub 2 multiplied by r. And then we will substitute the values. A sub 3, this will be equal to, our a sub 2 is 1/2, and multiply this by 2. So 2 multiplied by 1, that is 2 divided by 2. So 2 divided by 2 is 1. And our a sub 3 here is positive 1. We are now going to solve for a sub 4. So a sub 4. A sub 4 will be equal to a sub 3 multiplied by r. And then substitute the values. So a sub 4, this will be equal to, our a sub 3 is 1, and multiply this by r, which is positive 2. So our a sub 4 will be positive 2. So our a sub 4, positive 2. let us now solve for a sub 5. So a sub 5, again, this will just be a sub 4 multiplied by r. And then let's substitute the values. So a sub 5, this will be equal to, our a sub 4 is 2. And multiply this by r, which is positive 2. So 2 multiplied by 2 is positive 4. So our a sub 5 is positive 4. We now have the values for a sub 3, a sub 4, and a sub 5. Geometric sequence. Our problem, we have positive 100, positive 50. And we need to find the three missing terms, 1, 2, and 3. Okay, so let's call positive 100. This will be our a sub 1, a sub 2, a sub 3, a sub 4, and a sub 5. So to solve for a missing term, the formula is a sub n equals to a sub 1 multiplied by r raised to n minus 1. But we can use this if there are no consecutive terms. Okay, but since we have consecutive terms, we have 150, we can also use this formula. A sub n will be equal to a sub n minus 1 multiplied by r. Okay, so let's try this formula to find for a sub r. So our a sub r now will be equal to a sub, our n here is 3, or rather a sub 3, not a sub r. So a sub 3 would be equal to a sub 3 minus 1 multiplied by r. A sub 3 will be equal to a 3 minus 1 is 2 times r. So meaning to say the value of a sub 3 is just the value of the previous term multiplied by r. Let us substitute the values. A sub 3 would be equal to, our a sub 2 is 50, but we do not have yet the value for r. So let us find for the value of r. Now again, the formula for r, this is just the reciprocal of the two terms, of two consecutive terms. So we have 50 and 100, so r will be equal to 50 divided by 100. So to simplify, this will be 1 over 2. So our r is 1 over 2. So we can erase this. We can now substitute r here, which is 1 over 2. So our a sub 3 will be 50 divided by 2, so positive 25. And let us now find for a sub 2. So a sub 2, or rather a sub 4 rather, not a sub 2. So our a sub 4. So a sub 4 now would be a sub 3 multiplied by r. And then let's substitute the values. So our a sub 3 is positive 25. Multiply this by 1 over 2. So a sub 4 would be equal to 25 divided by 2, or this will be 12 and 1/2. Okay, and then let us now proceed. Let's find for a sub 5. But first, let's write here the values. For a sub 3, we have positive 25. A sub 4, we have positive 12 and 1/2. And let us find for a sub 5. This will now be a sub 4 multiplied by r. So a sub 5 would be equal to, so 12 and 1/2, let's use again 25 over 2 multiplied by 1 over 2. So a sub 5 would be equal to 25 times 1, that is 25, and 2 multiplied by 2 is 4. So 25 and 25 divided by 4. Okay, so let's convert that into a mixed fraction. This will be 6 and 1/4. So our a sub 5 here will be 6 and 1/4. We now have the values for a sub 3, a sub 4, and a sub 5. geometric sequence. Our given, we have a blank term, positive 15, positive 75, and then we have another blank term and positive 1875. So the first term, we will call this as our a sub 1. So this will be our a sub 1, a sub 2, a sub 3, a sub 4, and a sub 5. Now the formula for solving a missing term in a geometric sequence, this is a sub n equals to a sub 1 multiplied by r raised to n minus 1. Or we can also use the formula a sub n, this is equal to a raised to n minus 1 multiplied by r. Now on our given, we can find for r, or the common ratio, since we have two consecutive terms. So our r here, this will be the ratio of two consecutive terms. So we will just divide 75 and 15. So our r will be 75 divided by 15. So this will be equal to 75 divided by 15. This will give us positive 5. So our r is positive 5. Okay, now let us solve for a sub 1. We are going to use this formula. So again, the formula is a sub n equals to a sub n minus 1 multiplied by r. So we are going to solve for a sub 2. We will use the formula for a sub 2. So a sub 2 will be equal to a sub 2 minus 1 multiplied by r. Our a sub 2 here, this will be equal to 2 minus 1 is 1. So this will be a sub 1 multiplied by r. What is our a sub 2? So our a sub 2 is positive 15. And a sub 1, this is unknown. Our r is positive 5. So this will be a sub 1 times 5. So we can rearrange this. So to rearrange, we will have a sub 1 multiplied by 5 equals to 15. So to find for a sub 1, we have to cancel out 5. So to cancel 5, divide both sides of the equation by 5. Okay, so 5 divided by 5, we can cancel this out. This is equal to 1. What will be left on the left side will only be a sub 1. So a sub 1, this will be equal to 15 divided by 5, that is positive 3. We have the value for a sub 1, and this is positive 3. Okay, so we will now find for a sub 4. Again, we will use this formula to find for a sub 4. A sub 4 here, this will be equal to the previous term, which is a sub 3 multiplied by r. And then substitute the values. A sub 4, this will be equal to, our a sub 3 is positive 75. So this will be positive 75 multiplied by r. Our r is 5. So a sub 4 here, this will be equal to 75 multiplied by 5. This is positive 375. So our a sub 4 now is positive 375. So we have now the values for a sub 1 and a sub 4.